right, welcome. We're going to give a few, get you going instructions for the Unit 3 field study on water resources. All right, this one is supposed to take 4 class days. So what I'm going over today should take 4 days to complete. So do your best. When you first open it up, you might get a little overwhelmed. It does look like a lot of work, but remember it's 4 days worth of work. All right, part 1. In part 1, you'll need to download Google Earth, and there are very good instructions in your field study procedures guide about how to do that. Once you get Google Earth, you will need to calculate the area of your property. And again, there's specific instructions on what you need to do there. Once you have calculated the area of your property, you then need to go to either the Weather Channel website, Weather Underground, AccuWeather, whatever weather resource you want to use. Enter your zip code and find out what your monthly precipitation was. Again, very good instructions in the procedure field guide. Once you have done that, once you've calculated and not calculated, but determined the precipitation and you know the area, you can then calculate the volume of water. And I think of this as math teacher's revenge for every time I heard a student say, when am I ever going to use this? You're going to use it. All right, here's a sample data table, and I expect to see something like this for you. So guessing 10 inches, 5 inches, 5 inches, 20 inches. No, I want to see actual precipitation data for the months. I want to see actual mathematical calculations taking place for your actual property. Then going back to Google Earth, you need to calculate the area of your property that is paved or roofed. Yes, so the area of your property that has some kind of roof on it, whether it's for your house or your shed, then compare that with the area of your property that has vegetation or open dirt. So if you have a garden space, a lawn, All right, from that, be able to create the graph that they ask for in the other section, and then calculate runoff. Okay. Now, which brings us to part 2. Once we have this runoff, water that's not being absorbed into the soil or vegetation of your property, but is running off because it fell on asphalt or roof, where does it go? I chose Montpelier because this is where I live, but you can find the topical graph of a tropical map of the area you live by following the URL address in the procedures in your course. When you do, you'll get a topical graph such as this, and you'll need to analyze the graph to determine from your property where the water flows. And saying, oh, it goes to the street and it goes to the curb and then it heads out that way is not good enough. Okay? So, if you've never looked at a topographical map before, these brown lines tell you they are so many feet or meters apart in altitude, not in distance. And so that's why in this area of the map, they are quite close together. This area of the map, they are further apart, because the town is obviously built where it's flat. This is a hill or mountain just to the east of where I live. Now, if a drop of water falls right here, it's going to flow downhill. Once it flows downhill, it hits here, where is it going to go? It's not going to stop. It's going to continue to flow and follow the path of least resistance. It's going to follow gravity downhill. Once you get to the flat areas, it's a little harder to see these lines. So I'm going to kind of highlight them in red. So you can see that once it hits here, it's going to continue to flow downhill. Where would that downhill area be? I want to see multiple lines in your topical graph showing where it would flow. Because once it hits that topical, that's not where the creek bed is. It's going to continue to go downhill. So following something like this, see how it's going as fast as possible as it can, the shortest distance to the next ledger line. Now you would think that, so let's calculate right there to right there. It's about equidistant. Now I know because there's a blue line there that it's going to flow this way, but equidistant, it could have gone that way instead. Just like here is equidistant to here. So there are a couple of options. You can look for those water stream beds, or you can go by distance. Because once a stream is cut, it's easier for water to come and join that stream than to create its own path. All right, there you got a topographical map for you to try and calculate. Now, where I live is over in this area. So I would probably calculate it's going to flow down the street here and join the stream. That's probably the way I would choose. Because there's not a path. It's not going to go uphill that way. It's going to go downhill and then to the stream. Either way. So use that topical graph to try and locate or determine the path of your runoff down. Okay, the next part is going to look at actual water data for your facility, for your living location. There we go. You'll need to go to the U.S. Geological Service. You'll need to look at their water data. And again, this website address is in your field guide procedures. It'll come up with a map like this. You'll want to click on Idaho. Once you click on Idaho, let me get the next slide up, you'll get a map like this. For the first part, you will want to look at stream flow data. And what's highlighted right now is the possible locations around the state on rivers or streams that have some kind of flow meter on them. Not every river or stream will. So you'll want to choose one closest to you that does have instruments on it. It's that remote sensing again. Once you click on it, I chose the one at Bear River because that's the one closest to me. This is what popped up. This is the default. You'll notice when I grabbed this slide back in March of last year, the default was only giving me a week at a time. And that's great for part of this lab, but for the other part of it, you'll need a longer period of time. If you go back to that original slide, actually it's not there, you can change the date. Here we go. You can change the date right here with beginning and ending date because your lab asks for like a year. So on here you can see those trends as the stream flow changed in the river. Okay. Then you will also need to go back. Oh wait, this isn't it. This is the ground flow. Oh. Yes, I got to the wrong one. Yes, I'm sorry. I was getting my things confused. There is a historical one for the stream flow data. I didn't put the graph in. Yeah, I just did it for the groundwater. Sorry. This is depth to water level. So, groundwater. How far down do you need to dig before you hit water? In my area right here, it changes due to date from 345-ish, 343.3 feet to 345.8 feet. So about a half a foot difference from March 11th to March 18th. Notice how much it changes just in a couple of days. Yeah, and that's why I grabbed this one. Sorry, I thought I had yearly data for both, and I just pulled it for one. This groundwater data does change over a year. Almost a foot difference within a year. So if you were digging a well and you only went down 345 feet, you'd only hit water for, a few months out of the year. Right there. For about that long. The rest of the time, your well would be dry. Okay. Once you have this stream flow and the groundwater depth data, then you'll need to go back to Weather Underground or AccuWeather or the Weather Channel and look at precipitation data for your area for a year, and then correlate the two together, noting the date. If the precipitation level, say it rained a whole bunch in your area back in, say, December, how come the groundwater doesn't go up until January? How much time lag is there? Why is there a time lag? Or why isn't there a time lag? Did you expect there to be one and there wasn't one? Yes, so you'll need to look at the data for both of those and then compare it with the historical precipitation and then make some conclusions. And that is what the focus of the field study is. If you have any questions, send me a K-mail, give me a call, leave me something in the raise your hand section of the course. We can get through this. Anyway, here's something to smile to get you on your way.